Hello, we're going to look today at exercise 2b. Now this is where we look again at the mean and variance of a discrete random variable, but not necessarily an obvious one. So for instance, we've seen before how to find e of x. We've even found how to find e of x squared. What we're looking at today is what if I want to find e of, say, 3x plus 5. And in the whole, these are going to be linear transformations. I suppose we've already proven they don't have to just be linear, but these are the type that we're going to consider today, where we've got like a linear expression. So it might, for instance, be I ask you, what's the variance of 4x minus 2? And you'll notice it's basically a number times by the x, plus or minus some number. And they will always be, I think, like that, at least in part. Now, if we just have a look at this, then this basically, if we're going to find these things, we will be told something about the basic case, which is that e of x is something or other. So we might be told what e of x is, we might be told what the variance of x is, and asked to find these other versions of them. Let's have a look. So the exam questions tend to state the mean and or the variance, that, as I just explained. This then will give us a clue as to what then to do. And this is a rule I want you to copy down. In fact, both of them I want you to copy down into your notes. The expectation of ax plus c is related to whatever e of x was. And you notice this is no great surprise. For instance, if I tell you that e of x is 7, and I then say to you, what's e of 2x plus 4? How odd you'll go? Well, I bet it's just 2 lots of the 7. Add 4, which is 18. And that's actually all it is. This is, easy peasy. But this is where it goes wrong. The variance of x, let's say that was equal to, I'm going to make up number 3. And I'm going to say, what is then the variance of, let's do the same thing, 2x plus 4. Now this is where it's different, and you'll notice here my formula here, it says the variance of ax plus c is a squared times by the variance of x. Now this comes about because essentially if I have a bunch of numbers like 4, 7, 3, 2, however varied they are on my number line, there's 2, 3, 4, 5, 6, 7. I've got other numbers obviously either side of this, and this number line goes on forever. But I've got a 4, I've got a 7, I've got a 3, and I've got a 2. Now, what I want you to understand is if I was to times all those numbers by a number, for instance, say double them all, or as I've suggested down here, times them all by 3, then their spread of them will be multiplied by 3 out as well. So my numbers would become 12, 21, 9, and 6. Now these are definitely more spread out than these ones. In fact, they are 3 times more spread out. The standard deviation gets multiplied by 3 if the numbers are multiplied by 3. Notice the variance doesn't. The variance gets multiplied by a squared. So that's definitely new. That's not obvious. In this example over here, I've multiplied by 2, but my variance won't be multiplied by 2, it would be multiplied by 2 squared is 4. Notice another thing though. If I was then to, having multiplied them all by 3, which I'm doing now, I'm going to add 5 to them all. Adding 5 to them all, 17, 26, 14, and 11. Now I want you to think about these numbers in terms of how spread they are, out they are compared to these numbers. See, I don't think adding 5 has made them all any more spread out. They're the same distance apart from each other. So I don't think adding a number onto all the values, as long as it's the same number you're adding, I don't think it makes any difference at all. And that's what this formula basically reflects. It says the a multiplying by a does matter, but the adding of a number to the variance makes no difference at all. So notice what I do over here. I would basically, the 2 matters, the 4 doesn't. The 2 becomes 2 squared, and I times that by the 3. Adding the 4, completely ignore it. 2 squared times by 3, I get 12. And notice that is not doubled. In fact, it's 2 squared times bigger. And it's always the square, as this formula suggests. So let's look at some questions. We've got this farmer. He's meant to produce some cucumbers, it would seem, for a local supermarket. And he's used this new fertilizer, it says. The farmer... No, he doesn't say that at all. He's got to produce. I just assumed that. He's producing cucumbers. That he's meant to send them to the supermarket, and he's basically not very happy. They look quite small cucumbers, actually, looking at them. And so he's trying to manipulate these figures. He's cheating, basically. He's doubling all their masses. The real mass was 800 grams, it says. And the real variance was 120. And notice the transformation here is that I've got some new mass that I'm going to call y, and I've doubled it, so I've written y equals 2x, but equally I can just write this e of 2x as well. And it says, what is e of 2x? Well, I just think you just double the answer. That's very easy. Remember my formula from just now, e of x, ax plus c is ae of x. Now there's no plus c in my case, he didn't double it and add anything, he just doubled it. So I don't need to worry about the c. But I do just do what it says. So here I'm just going to go 2 times 800. He would basically say 1600. That seems obvious to me. The variance is the bit which is the peculiar one. The variance of 2x isn't 2 times bigger though. It's 2 squared times bigger. 2 squared times 120. Now 2 squared is 4 times 120 is 480. This is what we've got to get our head around. 1600 and 480. So here's another question. Now it's a piece of wood, it's actually a piece of laminate, it says. It consists of layers of material C and material D. The thickness of a layer of material C has mean 1. Okay, so let's just do this. E of C equals 1. And it's got standard deviation. So I can write, I'm just going to write standard deviation of C, like that. It's 0.1. And it also has a layer of D. So E of D has a mean of 8. Did it tell me standard deviation of D? Yes, it does. It's 0.2. If the total thickness of the laminate is considered as, oh, is this right? Is this what I've got? I've got different layers. So I don't know what the top and the bottom is, but it does seem to have 1, 2, 3, 4 of one and 3 of another. So that seems reasonable, doesn't it? It's 4c plus 3d, and this is the total thickness. And I want to know, given that, what the new mean and the new standard, or the new variance will be. Well, first of all, I suppose I should write down the variance of c is, it's always the square of this over here, and that's 0.01. And the variance of d equals 0.2 squared, which is 0.04. And this then becomes the mean and the variance of this. Well, notice I've got 4c. So again, using that rule I had just now, I think the e of y, or said differently, the e of 4c plus 3d. I think I've got to just simply do 4 times what I had before, which was 1, plus 3 times what I had before of d, which is 8. Now I think the e, the expectation is always easy. That's 4 plus 24, that's 28. I think it should be 28 millimeters thick. Now what about the variance? This is where you could go wrong. The variance of y, which is really just a posh way of writing the variance of 4c plus 3d. Notice these are both variables. So these are both variables. They're not like adding a number on. You're timesing 3 by the thickness of d. So this is where we have to use our rule for the variance. You'll remember we have to do 4 squared times whatever c was. C was 0.01. Notice it's the variance. Plus 3 doesn't get times by 3. No, it gets times by 3 squared times by 0.04. So that's 16. I think that's 0.16. I think that's 0.36. I think the answer is 0.52 millimeters. 0.52 and 28. Good, got it right. Cola is sold in bottles and cans. The volume of cola in the bottle has a mean. Right, I'm just going to do this. So E of B equals 500. And notice, give me the standard deviation. I don't really like the standard deviation. I like the variance. So I'm going to write the variance of B. Now, because they said standard deviation is 10, I'm going to write 10 squared, which is 100. Okay, the volume of Coke in a can, E of C, equals, it says 330. And the standard deviation, so therefore I'm going to write the variance of C equals 8, so I'm going to write 8 squared, which is 64. We want to see whether 2 times the volume of the bottle is more than 3 times the volume of the can. So they produce some dodgy formula. This isn't the dodgy formula for the transformation. Usually you'll be given that. It might be a wordy version of it, but usually you're given that. And we want to find the mean and the variance of y. Okay, so what is E of y? Now, posh way of writing that again, E of 2b minus 3c. Now here's a slight trick we have to be careful of. Well, not so much on the expectation, but certainly when we come to the variance, we have to apply a trick, or an observation might be a better way of describing that. At the moment, it's you do what you kind of expect, because expectation is fairly straightforward. So I'm going to do 2 times by whatever b was. B was 500. Minus 3 times whatever c was, 330. That's 1000 minus 990, that's 10. So this should be, you should, if you do this, if you have 2 bottles, should be effectively 10 more than 3 cans. Okay, now this is where I think we have to apply some kind of trick. Variance of y, or if you prefer, the variance of, what was it? It was 2b minus 3c. We have to square them, that's what our trick has said. Because again, we're not adding a number as such, we're just times in our variables. So 2b, just notice I'm going to have to do 2 squared times by whatever the variance of b was. That was 100. And this is where you've got to be a bit careful. I'm going to write plus a minus 3 squared. Because when I square this negative, it will definitely become positive. Variance of c was 64. That's where people go wrong on this. Everyone always takes away. But you can see that minus, when I square it, becomes a plus. This is 4 times 100. Plus 9 times 64. And that's where people go wrong. Let's do that on my calculator. 400 plus 9 times 64 equals 976, which is a huge number. 976. Bigger, much bigger than most people would have, expected there. And look, we're going to practice those. We'll practice a greater variety of them as well than the 2 or 3 we've looked at so far. But that is then trying to find the variance and the mean of a linear transformation. Notice we had 2 types. We had the type where we just had one letter, one variable. So, I tell you that E of x equals 5, and the variance of x equals 3, and I say find me the E of 2x minus 3. Well, it's simply 2 times 5, take away 3, which is clearly 7. And the variance of that is clearly, ignore the 3. Remember what I said about ignoring that 3? If no letter there, ignore it. So it's 2 squared times by 5. That's 20. That was the first type. And the second type was when you knew something about 2 different letters. You might have known also that E of y was 7, for instance. And I asked you to find, I don't know, E of 2x plus 3y. Now those ones, a little bit harder, but that's what most of the examples were that we were doing. So hopefully you can do those, and obviously the variance as well. Watch out for negatives on the variance. Look, that's it. So fingers crossed you will be able to do those now.